Okay, our final question in section 12.5.1 on planes is practice problem 23. We want to find the cosine for the angle between these two planes, x plus y plus z equals 2, and x plus 2y plus 3z equals 8. Normally, this would be a difficult problem because finding angles between planes is a tricky proposition. We would, after all, need vectors that lay within the planes that also were coplanar themselves, and that plane would need to be perpendicular to the plane of these two planes in order for those two vectors to truly represent the angle between the planes. But we can take an easy way out. The normals for these planes are easy to find, and because the normal for each plane is perpendicular to the plane, the angle between the normals will be the same as the angle between the planes. So we're not actually going to find the cosine of the angle between the planes, we're going to find the cosine of the angle between the normals. So let me name the two normals. This normal will be u, and of course it'll be 1, 1, 1. And this normal will be v, and of course it will be 1, 2, 3. Well, now that we have the vectors that represent the two normals, and I know that the angle between these vectors will be the same as the angle between the planes, I'm just looking to find the angle between two vectors. And that's pretty easy. That means taking the dot product. So u dot v will be equal to the magnitude of u times the magnitude of v times the cosine of the angle between them, which means if I want the cosine of this angle, I need to take the dot product and divide it by the magnitudes of each. And that should be pretty easy. The dot product is just going to be 1 plus 2 plus 3, so that's 6. And the magnitude of each, this is going to be the square root of 3. And this one's going to be the square root of 14. 3 times 14 is 42, so this will be 6 over the square root of 42. Or if we want to rationalize that denominator, it'll be 6 radical 42 over 42, and of course 6 over 42 is 1/7, so it's the radical 42 divided by 7. We could make a decimal equivalent to that too, but it isn't really necessary. This will be the cosine of the angle between them, and if we were interested in the magnitude of the angle itself, we would just take the inverse cosine of whatever this decimal approximation was.